Welcome back, everyone, to the Hot Mix, an InstroTek podcast. I'm Anthony.
And I'm Maurice.
And today we bring you another very special guest. Not only is he extremely handsome, but very, very smart.
Extremely, yes. And this is funny because this guest was just kind of in the area coming to see us, and we thought, what a great opportunity to have Mr. Andrew Cooper. Come on in, Andrew.
Yeah. Hi, everybody. Welcome.
Welcome to the podcast, Andrew. Andrew's coming all the way from Europe here on a little business and stopping by. Barcelona, Spain, and just stopping by to show us a new technology that he's developing with a lot of people here in the American industry. But first, Andrew was part of Cooper back in the 90s. You and your father were part of the ownership of that company at that time?
Yeah, my father started it. He worked at the University of Nottingham since '68.
Okay.
And whilst he was there, he developed a piece of equipment called the Nottingham asphalt tester with his professor, Stephen Brown. That did pretty well. So we went part-time at the University of Nottingham. It did better.
Got some traction.
Then we made a few more machines and, there you go.
That's Cooper. Yeah, I remember Cooper. I mean, when I first started in the industry, Cooper was a big name, obviously from the UK. And then somewhere along that timeline, you came over here and bought Cox & Sons, correct? Which is a big brand out of California. They were very well known in Caltrans and all over the West Coast. But when did that happen?
2016. We saw that around the world, the AASHTO and ASTM standards were being used more and more by people. Europe was a bit fractured, so the French would have their standards, the Dutch would have theirs, the British have theirs. But when we wanted to work in China, Africa, other countries around the world, they'd always be quoting AASHTOs or ASTMs to us. So this opportunity came up for Cox & Sons, and obviously they had a great reputation for the machines they produced, Jim Cox, over the years, and we took that. It was helped by the fact it was in California, which was obviously a nice state to move to. It was a great experience.
Yeah, I remember when I first met you, you were kind of moving things forward for them with a lot of different products, but one of the ones that you're most known for is the Hamburg wheel tracker that you kind of helped Cox develop, and is still in the industry and doing, you still see it around.
Yeah, that's one of our first products. I mean, we had a lot of history of making wheel trackers. They were used in Europe and various countries without water, so we had to make one that used water. But luckily, we had this mechanism which was truly sinusoidal, and that came in very beneficial when the standard was changed. So that was a stroke of luck, thanks to my father. And awesome. Great times.
I mean, we're talking about waveforms, right? They got to be purely sinusoidal, right?
That's my favorite type.
Yeah, that's it.
You got to go with the pureness. Yeah. A true purist on the sinusoidal waveform. Yeah, so we understand.
It's a hard word to say.
I know it is, especially all together. But anyway, Andrew's now here. Obviously, those companies are companies he worked for, but now he has his own company, still developing, still engineering. And a lot of people that know Andrew from the industry or will recognize Andrew from this podcast know that he's a great inventor, right? He's come up with a lot of ideas, incredible engineer, very smart, knows our product extremely well. What?
It's just like, yeah, sure. I'm a great inventor.
Yeah, whatever.
And today he has one of his newest innovations for our industry, which is called MiAS. And tell us a little about MiAS and kind of what brought you to this point with coming up with this jig for iFit.
iFit, an Ideal CT.
Ideal CT, SCB, yeah.
Well, I guess it was a lot of different factors that came together. I found myself with nothing much to do, no job. And
so you're an employee there hanging out somewhere in Europe, and you come along.
Yeah, I love the honesty, man. It's so good.
It's very refreshing.
It is.
There were, I remember being at TRB, must have been 2023, and I saw some presentations from Imran Al-Qadi and Bill Butler, and they were talking about the use of cameras. So I put a few bits together and thought that they were just talking about using this artificial intelligence out in the field, and in the lab, it hadn't really been discussed at that point in time, as far as I could recall. And I had an idea which probably took some of itself from what my father did back when he was at the University of Nottingham, that you had these tests, namely the ideal CT test, where we apply a force vertically, and they were looking at the load curve and seeing from the load curve how that could predict performance, the cracking performance of the material. But the load curve alone was not sufficient to actually tell us about all the materials that might go into these mixtures nowadays, because unlike 20 years ago, where it was mainly just asphalt, you have modified binders, you have rubber, you have fibers, lots of wrap and RAS and different things in there. So it's very difficult for one test based just upon the load curve alone to sort of tell you what was happening there. And so knowing that this test that my father, that had been around since I was a kid in our household, measured the horizontal deformation as well, I thought it would be very nice if you could measure the horizontal deformation. But the problem with these tests is that they're destructive. So when the test is completed, that's in 2 halves.
That's right.
Mm-hmm.
And if you use an LVDT or an extensometer, that's a very expensive way to proceed with a test, because you have a very good chance of breaking these things.
You did something a little bit different here, which is you mounted cameras on either side of the face of the sample. And what are you able to do with these cameras now that you've done this?
Well, the cameras view the side of the specimen. I look at the pixels or look at the images that they produce and convert those into measurements. So I can convert pixels into millimeters, which enables me to look at initially the horizontal deformation, but now I can do other things as well, such as the vertical deformation, which tells me whether the machine's working correctly, is actually producing 50 millimeters a minute. And also look at how, although it isn't a cracking test, there is a crack that appears, and I can measure the crack, the speed of its opening when it first starts to open. And I believe that may be useful as an additional parameter that can be included within the ideal CT test to give us more information about what's actually occurring.
So basically you're taking what we already have, and you're adding almost QC to that process in terms of being able QC QA and being able to pull more data out and prove maybe what you're already seeing deeper.
Yeah, I mean, there are lots of studies where in nice research labs, they've used digital image correlation, which is a high-level way of looking at images and calculating deformations or strains or speeds from these images. What I wanted to do is to produce something that could be used in routine testing. So I've simplified that, and the use of AI and image analysis enables us now to look at this without having to have very expensive, $40,000, $50,000 pieces of equipment. You can do this relatively cheaply. And I wanted to produce something that could be used in regional labs by not necessarily people doing a master's or a PhD, just a regular user, that they could get something more from the test, and that the test wouldn't take any longer to perform than it does currently.
Right, and really what you did too, and this is why I like the design of this, you made it look nice.
Yeah, it does.
It's a nice piece of hardware. You designed it very nicely. It fits in pretty much all the standard monotonic loading machines that are out there, right?
Correct, yeah.
You've tried it in a number of them, right? And it works just fine, fits fine. And that was one of your design aspects. You told me a little bit about that. You had to make sure that this fit inside just like a Lotman head or a Lotman jig.
Yeah, that's right. As I say, I mentioned digital image correlation before, and that generally uses cameras which are quite far set back from the object that they're looking at, and so I've moved in very closely, and I use a very wide lens, and it enables me to get in close. I understate the images when I look at them with the computer, but it does mean that this can go in your very nice frame, in my friends at Humboldt, and their very nice frame as well. In everybody's frame, the on which you can run these tests.
Yeah, absolutely.
What would you say is the biggest benefit that this brings to BMD right now?
Number one.
Good question. Very good. I like that one.
Question.
I think that we can reduce the COV which is an issue for a lot of people, where you may have different machines or different levels of user. A COV may be down around 15%, something like that, but can jump up to 30%. So we can reduce that through the use of the additional measurements that we get from this system. Additionally, as I said before, that if we test polymer modified binders or ground tie rubber or something that's the test as it is now doesn't pick up, we can actually start to say this is how this material, this modifier improves the properties of these materials without having to go to a more expensive test or a test that will take longer to perform. So I would say that those are the two at the moment.
Well, those are big ones. The COV has become more and more prevalent as the balanced mix design has grown. I've found, first it was like, let's get the speed down, let's get the parameters down, let's find out what the number is for our state. And now it's like in between, if we're doing a lot of 3 specimens versus a lot of 5. What's the COV now? Can we get that? One of the big things that we wanted to do with our software is make it to where you could graph all of them together so you could get an active COV right on your first run, so that they didn't have to do the calculations on the back end. So you're giving that even, and you're getting it as a more robust measurement now, and you can even get a little bit more granular and bring that even down further.
Yeah, and if you reduce your COV, you can have a tighter specification. You have to have a wider specification because of the variability in the results. So if you have more confidence in what you've produced, you can tighten up those specs, which actually is good for everyone involved in the process.
Mm-hmm. Yeah, I think what you're seeing here, and this is what I love about new technology, is really the evolution of a test that most DOTs feel comfortable with now. They feel like, hey, it's giving us fairly good information on various mixes. But the one thing that Andrew said that I really like is that now you're able to look at other mixes that maybe the current test isn't picking out the differences in, right? It's giving you kind of the same numbers, but you don't know, is it really working? And those are, modified asphalt products that, for better or worse, we're diving into and use it as an industry. And I think this really is looking at how can we make this test better with what we have. And also, like you said, anybody in the lab can still do it. Anybody that's running the iFit can do it. You don't have to be at a university level with a very high-end piece of equipment, and that's what Andrew's brought to us today. And I really think it has a place moving forward with some of these tests.
100%. I feel like this is kind of what we've been looking for, what we've been needing. So, great job.
Congratulations,
I've just
Andrew.
been waiting, and here you are. You're like, just delivering the great news here.
Well, I've got to say that, Fuji did all the work. So prop to Fuji for producing the test. All I'm sort of proposing is some slight enhancements to that, because everybody loves the test. It's so easy to perform.
Yeah.
And, we want it to continue.
We all stand on the shoulders of great men, I feel like. So
Amen.
We got to give the props.
Thank you, Fuji.
Dr. Fuji, yes, down in Texas A&M, a brilliant engineer as well, and obviously this is I think maybe the next level in the testing. So we're here for it. If you want to find out any more information on this product, please contact Andrew. We'll put his website on the bottom. Obviously, InstroTek is also going to be helping Andrew commercialize the product, so you can contact us here at InstroTek, and we can give you a little bit more information. If you're interested, you're seeing this, just contact us via our website.
Yeah, awesome. And thank you all so much for tuning in. As always, we really appreciate the support. Remember to like and subscribe. And thank you, Andrew, for coming on the show. And
thank you.
Probably going to get thousands and thousands of views now because you're here.
It didn't. You didn't hurt, did it? You're okay, right? This was good.
Yeah. So was
It's
easy.
No, it's not really my kind of thing. But yeah, you carried me along.
We actually
you carried me.
We had to force him. That's basically what he's saying.
Thank you all so much for tuning in. We really appreciate everything. And just remember, keep it hot.
Keep it real.
Keep it real hot.